Good afternoon, guys. Wherever you might be this afternoon, at your home, in your dorm, in the library, in your car, wherever you might be, come on in here and let's talk about GIS, shall we? So this Thursday is Lab Practical 2. All right, and so we're gonna do it just like last time, unless you have a really good reason that you can't come to lab to do it. My expectation is that you sign up for one of those 3 time slots on Thursday, 9 a.m. till 11, 11 till 1, or 1 to 3, and during that 2 hours, you start from scratch with the resources I gave you, and you complete the task. And submit your final answers in the inline form, and submit the layout I described. And I am going to create a shared drive on a shared folder on the network attached storage drive in the lab, which is accessible from all the computers in the lab, so that when you're done, you'll be able to export your final results as a project package or a map package. Which will be better. Shoot. All right, I'll figure that out and let you know. But you'll be able to share your final results that way. So I'll be able to look at your entire work when I'm grading those practical exams. Okay, so that's on tap for this Thursday. If you have a really good reason why you can't make it in the lab, send me an email, and I'll take a look at that, and we'll come up with an alternative process. Okay, an alternative process. I've been adding a lot to the. Oh, that doesn't work. Here we go. I've been adding a lot to this this Google Slides presentation. New material since the last exam. The last exam kind of went through here, and so I got lots of new material about dealing with raster analysis of raster data, which was the focus of one of the chapters. Tools like the near tool, and what is these derived raster data from a digital elevation model. Is still a digital elevation model on here? Well, it's on this slide. Digital elevation model, which is a raster with pixel values corresponding to elevation. So, knowing what that is important. Slope, hill shade, information about the model builder, which you now have a lot more experience with. And not only that, but what do the colors mean in the model builder screen? Some other GIS tools. And then after our discussion last Friday about the Landsat program and now we were using Google Earth Engine for that discussion, but I created a little summary slide with some information about the Landsat program, which is good for you to know. Landsat imagery is probably still the most widely used satellite imagery for Earth's surface, at least in the United States. And the latest iteration of Landsat program is Landsat 8, satellite that was launched in 2013. So the next Landsat satellite is scheduled to be launched in 2021. And then normalized difference vegetation index, NDVI, which we calculated last Friday for some data from Landsat. And we talked about what it means. So here's a summary of that. So I'll have some more stuff to add to this, all right, and in the coming days. And I'll keep you posted about what's there. Is the test this Friday? No, the test is not this Friday. What is the test? Hold on a second. This test is scheduled for Monday of next week, November 9th. Would you like me to move exam 2 to, let's say, instead of Monday of next week, Friday of next week? Would you like me to do that? Because I think, you know, at this point, the rest of the semester, most of what you're doing is going to be your independent project work. So we're a little flexible. Yes, 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 that would be lovely. All right, it's done. You're gonna have your exam 2 on Friday the 13th. Next Friday, Friday the 13th. All right. So it's no longer, it's on the syllabus. It's scheduled for Monday. It'll be next Friday. All right. So focus this week. Focus your energies on getting up to speed, so that you can come in and you can just knock that practical exam out of the park. All right. All right. So I'll remind you about that the exam is next Friday instead of next Monday. Okay. There was a question about a student emailed me and was asking about the data for the practical exam. And let's go take a look here. Right, so it would be under assignments, lab practical 2. So this data, the Geo database contains 4 feature classes, and it's in the resources folder. All right. So if I click this, it should download. It is. It's 39 megabytes. It'll take a half a minute here to download. And when this downloads, I'll unzip it. It's a zipped archive. I'll shift this over to my desktop. All right, so it's done downloading. I'll double click on it. It opens up. So this is a peek inside of that zipped archive, and I'll just drag this folder to my desktop. It's already there. I'll just replace it. Maybe I shouldn't have done that. All right, it's there. So can you see that? Yeah, you can see it up here. So it's you can also see, whoa, infinite windows. It's up here. It looks like it's a directory, because it is. You open it up and it's got all these files in it. But this is a geodatabase. All right, that's what I shared with you, a geodatabase, GDB. See, there's a file extension there. But from Windows perspective, a geodatabase is just a bunch of files that are organized in a folder. But when you open up ArcGIS Pro, let's move that out of the way now, and let's do a new project. Catalog. And so when you create a new project, there's a geodatabase that's automatically created. My project here was just the generic vanilla name, My Project 11. But remember, if you right click on this databases tab, are you able to see this? I'm not sure if you can. Let me move it over this way a little bit. So you right click on the database tab, you can add a database. Okay, so I'll click that, and then I can navigate to, it's on my desktop, database, there it is. Okay, Practical 2 NPS public lands. All right, so now it's there, and I can peek inside it, and I got all these different layers I can then add to my map. Here we go. All these layers, these feature layers, there's 4 of them. All right, and they'll add. So Aaron asked, is there homework due Thursday? There was another assignment on there, which was I wanted people to share. It's not mandatory. I think I know what Aaron's talking about. So Aaron's saying in the assignments, there's an assignment. It's a 2-point assignment. It's not mandatory that you submit it. I just wanted people who had completed the lab, the layout for their LA River project to share it with me for bonus points, for 2 bonus points. But it's not mandatory. It's optional. All right. So you'll see that when you click on the assignments. It's again, it's just optional. You don't have to complete that if you don't want to, but if you do, I'm going to give you guys 2 bonus points. All right. So anyway, the student who asked me about the data. Okay. Let me see. Gosh, I can't remember who it was now. But one of you asked me about the was saying they are having problems getting the data from Sakai into ArcGIS. You know, that can happen in a number of different ways. It could be that you just forgot to unzip that geodatabase like I did. You peek into that, it's a zipped archive, and then drag it to your desktop or wherever you want it, and then you can add a connection to that database in ArcGIS Pro. So you can view the feature classes it contains and add them as feature layers on your map. All right. So if that was you who was having trouble with that process, and you still are having trouble, let me know and we'll try to figure it out. Okay. All right, let's go back to Chrome here, and you'll notice under the assignments, oops. Okay. Yeah, so here's that optional LA River project final layout. Not mandatory, optional. Lab Practical 2 for this Thursday, and then I've created an assignment for your final project as well. So let's peek at that, and let me open student view here. Okay. So for your final project, and we've talked about this some already, but here it is in more glorious detail. This end of semester GIS project is what you're going to be spending, with the exception of the lab this week, which is the practical exam, and I have to take a look at the lab workbook. There might be one more thing in there that we might want to do together, but if not, you know, the majority of the time for the rest of the semester is going to be your time to work on this final project. Okay, we have the practical, and then there's the exam, and you know, believe it or not, you know, I was looking at the calendar, and there's only, this is week 11, 12, 13, 14, so we only have like 3 more weeks of class, and then Thanksgiving break, and after break there's a couple days which are called flex days, and I don't intend to introduce any new material during that time. It'll be a time for you guys to work on your projects, all right, and I'll be available to help you, but we can't meet in person during that time. It's illegal, and which means you can't use the computer lab resources during that time. Okay, so if you're dependent on those resources, you really got to knock everything out in the next 3 weeks. You got to knock your final project out in the next 3 weeks, and that's very doable. Okay, the scope of what I'm expecting from you is not. I don't think it's too enormous here. All right. I want you to formulate a question that can be answered with GIS, and I gave a concrete example here, and we're actually going to pursue this one together. So there's a place in Louisiana that's called Cancer Alley, and it's this region through the center, kind of spans the area, the line between New Orleans and Baton Rouge, Louisiana, where there's reports of elevated cancer rates. And this is also a very industry heavy corridor. A lot of petrochemical plants are located in this area. And so I saw a documentary recently called Mossville, and it was about residents that lived in the vicinity of one of these plants that produced that released a lot of a chemical called chloroprene, which is a precursor in the manufacturing of neoprene, into the environment. And anyway, so I was interested in this topic. All right, this topic of cancer rates. You know, I can go out and get data, and I can look into it myself to see if, you know, are there elevated cancer rates in this area, and if so, you know, how bad exactly is it? So we can look at it a little bit. So you need to formulate a question that you can answer with a GIS. So here's a question I pose: how does the cancer rate among residents living close to chloroprene releasing petrochemical plants in Louisiana compared to the rate among the general population in Louisiana? The parameters that I have set out for you is you must use at least 2 separate feature layers, i.e. feature classes in a geodatabase, as a starting point for your analysis. So these might be something that you have to build a little bit before you can go. So counties, in Louisiana, counties aren't called counties, they're called parishes. I spelled it wrong, I wrote parishes. It's parishes. Now I gotta fix that. Oh, here we go. It's parishes. There we go. They don't call them counties, they call them parishes in Louisiana, with cancer data for each and locations of chloroprene emitting facilities. Okay, and that way, then you must use at least 2 analysis tools to arrive at the answers to your question. So for this particular question, it seems like the tools I'll use are a buffer tool, so I can create buffers around these plants, and then use a tool like Summarize Within, so I can figure out, well, how many cancer rates are there within that buffer around each of these chloroprene emitting facilities. Okay. And then, you know, so you'll do your analysis and then turn in the following: a geodatabase containing all input feature classes needed to carry out your analysis. All right, and the second thing here is new. I haven't asked you to do this yet, but I want to ask you to do it once here. I want you to build a geoprocessing tool using Model Builder like you did with the LA River, Lesson 7. And it's going to accept the input parameters and input feature classes. It's going to carry out the analysis and produce the results that answer your question. All right, so we're going to, you know, I'm going to do this with, and so I have this question and I have an idea of where I can go get data, but we're actually going to do this together. So we're going to walk through the whole process together. All right, a PDF layout to show a summary of your data and results, and then the last thing is a 1-page summary of your analysis and results. So, um, so the way I look at this is like, in terms of the GIS work that you're doing, it's about the same amount of GIS work as you would do in one of the practicals, the practical exams, but there's more upfront work because you've got to find your own data, all right? And there's tons of it out there, and so you might look for data first and then make your question up based on what data you can find, all right? That's typically not how science is done, but this is a class project, all right? So maybe your question is a function of what kind of data you can find. We'll probably have a chance to go through more than one of these, examples in the coming weeks. Okay, so the way I'm going to grade you here is you are going to share your geodatabase with me, and you're also going to share your geoprocessing tool with me. And I'm going to open up a new project with your geodatabase, and I'm going to run your geoprocessing tool and see if it gives me an output that matches your one-page summary of your analysis and results. This doesn't have to produce the map that you share, the layout that you share. That's separate. You do that by hand. You create a nice looking PDF like you did for the LA River project, and you submit it. All right. But this one-page summary of your analysis and results is just going to be like, this is the question I wanted to answer. This is the data I needed. This is where I found it. I use these tools because it helps me to find this answer, and then here's my results. Short, sweet, and to the point. But then the idea is, I have your geodatabase, I have your geoprocessing tool that you made, your model builder geoprocessing tool, and then I can run it, apply it to your geodatabase, and I should get the same results that you got and you shared. Okay. So that's my goal here. All right. So let's see. It's 1:30. Let's get started on answering this question, this example, concrete question that I got interested in, and I don't know what the answer is. Okay. I don't know. I know that this region is called Cancer Alley. Presumably there's a reason for that, but we're going to actually look at it ourselves. All right. So, all right. Okay. So I'm going to need cancer data, and I'm going to need locations of chemical plants in Louisiana. So I got to go out and find that. I have an idea of where I'm going to find this. So I do know you guys might remember this from intro environmental science classes. The EPA has this database called the Toxic Release Inventory. And I'll switch over to Chrome. And so this database contains a wealth of data on point source polluters, point source locations of point source polluters. There's this nice. This has changed a little bit since the last time I was here. So you can search this database. Let's see. This looks like sort of an interactive version of the database. Let's go to a state. Let's look at Louisiana and see what we got here. This is the fun part. You guys have been working hard all semester. Now you get to have some fun. Let's just look at a map. All right. So here is a map of all of the facilities. Let's just click on one with this one. This is U.S. Army, JRTC, and Fort Polk. National Security and International Affairs. So that must be like an Army base. here is so here you can see this region right here. So down here is Louisiana, up here is Baton Rouge. So this corridor from New Orleans down here to Baton Rouge, this is the corridor that's called Cancer Alley. You got all these factories or industrial centers, not all factories, that are point source polluters. So here's a fertilizer plant. Mosaic is a big fertilizer plant. Pesticides, fertilizer, and other agricultural chemical manufacturing. DuPont, Pinnacle Polymers, refining, Valero Refinery. So you see a lot. There's a Occidental Chemical Corp, a huge number of industries in the petrochemical industry. Westlake Vinyls, vinyl production. Somewhere in here, I'm not even sure where this town is. It's near, I think it's near Laplace. There's a place here called Donka. I'm sure it's in here somewhere. It's well, let's filter. So I know up here, filter based on chemical. It's based on chemical. So why'd that zoom in so much? What the heck? What the heck? Why? What happened? Let's clear all selections. All right, let's try that again. State. Ugh, what the heck? Louisiana, check. Okay. Let's apply a filter here for a specific chemical. It's called chloroprene. Here it is, chloroprene. Let's apply that one. And all right, there we go. So we got a subset of. There might be two in there. There is two here. All right, so they're labeled DuPont here, huh? Okay, DuPont. So you know, click on one of these guys. And you can go, whoops. You can do a facility summary. Releases. So obviously, you know, one thing we'll do, well, let me zoom in here. So if we're focused on chloroprene, oh, now I selected that one thing. There's some facilities that release a lot of chloroprene and some that don't. But let's just focus on chloroprene. There's other things that cause are potential carcinogens, but let's focus on chloroprene. Get rid of that. So these plants release a lot of chloroprene. Okay. The one thing that's missing here is there's really no way to download this data. I don't see anything here, but I know that there's another version of the TRI. Let's go to here, this page. It's called here it is, the Explorer. And we'll go here. So it's the TRI Explorer. And so let's get facility level data for, let's do 2019. and we want a specific state, and we want a specific chemical. So you guys can't see that pop-up window, can you? Here, let me switch to desktop view. So specific state, Louisiana, and a specific, why didn't that work? Here we go. Let's see, chloroprene, where are you? Oh, so many things being released. There it is, chloroprene, done. So it's telling me about the data set. The default is data source 2019, updated data set, released October 2020. Select 2018 updated data set. I'll just leave it on the default 2019. You know, I don't know if using this data is the best data set to use. It's newer, but that means it might not be curated as well, or you know, when you update things, you correct data entry often. We're going to include these metrics for total release of chloroprene. But this is important. I want to be able to map these locations, so I want the latitude and longitude. All right, and then I'll do generate report. Oh, that was quick. It's giving me 5 locations. There it is. Denka performance elastomers. This is what was on the map as DuPont. I wonder if DuPont bought that. I don't know. And then down here you can download this data. So let's do that. All right. And let's put it on my desktop over here. Okay. And now let's take a look at this data. So I have it right here on my desktop. Wait a minute, that's not. No, that's not the right one. Hold on. That must be from another time. We'll call this chloroprene release Louisiana 2019 from the toxic release inventory. All right, let's take a look at this. Yeah, this is what I was looking for. So there's a lot of stuff in here when you download data from these government databases. It's not unusual to have something that looks like this. So you got to clean this up before you can open it in ArcGIS. Possible data log. So there's you know, information about your query down here, totals. So we'll get rid of all those, clear all those rows. And then you got some extra stuff up here. Clear those rows. Actually, I should have deleted those rows so everything pops up. And you got one row up here to delete. Okay, so you know, you'd probably want to save this as a new version because all that other information is. But this dang, look at that. I mean, this is the most important release source. This Formosa Plastic Corporation, Louisiana, is a pretty big emitter of chloroprene too. But everything's pretty much, you know. So maybe, you know, when you look at this, like if you're interested in cancer rates and chloroprene, this is sort of the only show in town. Look at that. I don't know if, can you guys see that? Zoom in a little bit here. I mean, look at that. So this is the chemical chloroprene, and this is the facility, this Denka facility that was the focus of that documentary, Mossville, and that I saw recently. And man, I mean, it kind of dwarfs releases at these other facilities. So maybe, at this point, um, we want to, actually update our question. I'm already, my question, as I stated it, was pretty general. The release from petrochemicals, and I've already refined that. I'm focusing on a specific compound that's released. Okay, so that refines the scope of what I'm looking at. And after I see this data, I think that what I need to do is just focus on the Denka facility, or maybe the Denka and the Formosa plastics facility. These other facilities aren't in the same league as Denka when it comes to release of chloroprene. But let's not do that just yet. But if you look in here, you see I got latitude and longitude. All right, and that's all the data I need in order to make a feature class that maps the locations of these facilities. Just no data. I guess that's what a dot means, no data. All right, I'll save that. Okay, so I got that saved. Let's come into, I had this project started. I was demonstrating how, let me get rid of these. There we go, deleted all that stuff. So let's make a feature class out of this chloroprene data set. So there it is. I'll just drag it in here. All right, I could put it in my project folder and then add it, but I added a standalone table. Now I should be able to open this and view it in here. All right, so this, let's go back. Oh, that's weird. There's a bunch of extra rows here. What the heck is that all about? Let me see if I can fix that. I don't know why, but there's a bunch of extra rows in here. Just delete everything. There it is. Okay, I'll drag it back in here. All right, let's take a look. Okay, so I got rid of those extra rows. There's these 5 rows. All right. Yeah, I think I did. I cleared a paragraph, but didn't actually delete it. Okay, so now, does anybody remember what I do now? I want to create a feature class. I want to create a feature layer here, and a feature class in my geodatabase over here, which is showing the point locations of these 5 facilities. Does anybody remember how to do that? So when did we do this? When did we do this? We did this. We did this, okay? I just can't remember when we did it, which lesson we were working on. But we did this. We did this. In this case, the location information we have is geographic coordinates, latitudes and longitudes. And let's assume, I don't know, I guess we could dig in and see if this is true, but let's assume that they're WGS 1984. Geographic coordinates. They use the WGS 1984 geographic coordinate system. These are facilities that are pretty big, so if you're off by a couple tens of meters, it's not a big deal. Does anybody remember the tool name? This is a tough question. I can't remember what we had location data for. Oh, I think it was like parks. There was some parks that weren't in the parks feature layer because they were so new, and so we had to add them. Sound familiar? You give up? So the tool we can use here is XY location to point. That's what it's called. All right. So let me search for it here. XY table. Sorry, XY table to point. Here it is. So just to be clear here, you know, so this tool is something that many of you are likely to have to use because with these government databases, you'll be able to get locational data that includes latitude and longitude, but you're not going to get like a feature class. You won't like download a feature. I mean, you can do. I'm sure that some data out there already exists as shape files or feature classes that you can just download and import into ArcGIS Pro. It appears as a feature layer on your map, and then you're ready to go to the next step. But lots of data sets won't be like that. It'll just be data, and it's you know, it's geospatial in nature in that it's data that is about specific locations, but it won't be in a form that you can just drag and drop onto your map. You got to do a little processing, but it's no big deal because if you have latitude and longitude, you can create a feature class from that. All right. So this is the tool, XY table to point. I'll have to add that to the Google Sheets. And the input table is this chloroprene release, Louisiana 2019. And let's make the output chloroprene emitters. The X field, so that's, you know, left and right, that's longitude. And the Y field is latitude. It defaulted to using WGS 1984, so we're all set. Okay, and so if I run this, and it should import all these other fields into the feature class. So it created. Let's make the symbology a little bit more visible here. So it worked. It created this feature class, and it mapped those locations, those 5 locations. All right, and 4 of them are in this region between New Orleans and Baton Rouge, and 1 is over here near Lake Charles. And if we look at the attribute table, yeah, it imported, created this feature class and added it to my map. There is the feature class, and added it to my map. And it imported all the columns from that table as well. So if we wanted to, you know, filter by the total amounts of on-site release, we could do a definition query and narrow it down to these 2 sites or these 3 sites if we wanted. All right, but mission accomplished. We got one of our data sets. Okay, so the other data I need is cancer data, because I wanted to see if there is any difference between cancer rates near these facilities. I haven't defined what near means yet. You know, is near 10 miles? Is it 50 miles? And yeah, definitely. Oh, sorry. It's a long Halloween weekend. Too much candy. You know, you could get different answers depending on the data that you use in these definitions of what does near mean. You know, maybe near is 10 miles, maybe it's 50 miles. So that's a parameter of the analysis. It's a parameter of the analysis. You could, in your model builder tool, it should be made a parameter that you can actually, you know, put what you mean by close or near. So let's try finding some cancer data that's on the county, or this is Los Angeles. This is Louisiana, so not county but parish level, and that might be the best we can do. We might be able to get data that's even more spatially refined, down to the census tract layer or level or something like that. But I'm pretty sure I know where to go to find data on cancer rates at the county level. So let's start there. All right. All right. Oh, I closed my web browser. CDC cancer data. Yeah, I think so. This is where I went to find data for remember your very first practical with lung cancer data. So it came from here. Public use databases. Access the data. Let's try data visualization tools. All right. Okay, and let's see, over U.S. rates of so we want a specific state or county, so let's click that, and then make this the state of Louisiana. So here, this is that region of that's called Cancer Alley, right in here. So what are we looking at here? This is all types of cancer, all ages, all races, ethnicities, male and female, 2013 to 2017, rate per 100,000 people. Okay, well these counties seem to be bluer than average. They seem to be in this region. I guess we'll keep all types of cancer. We're not going to be that. We're not going to discriminate. Rate of new cancers, rate of cancer deaths. So you got some choices here. You might want to number of new cancers, number of cancer deaths. I guess we'll just do rate of new cancers. But this is a decision, right? We got to decide which data we want to look at. So I've decided I'm going to look at rate of new cancers. All right, and then we got this handy dandy export tool. So I should be able to export this data. So let's do that. I can export a map. I wonder what that is. Oh, it's a JPEG. That's not going to help us. Let's export the data. Alrighty. And then I'll move that to the desktop here. Double click on it, take a look at that. Alright, so we got area, Louisiana. It's all Louisiana, so I could delete that. County, cancer type, all types. Year. I don't know. Maybe I won't delete that other stuff. Just leave it in here. This is kind of ugly. So do you guys see why I say this data? This is the raw data I just downloaded from that website, and it shows me what I want: age adjusted rates, case count, population, and for every county in Louisiana, or sorry, parish in Louisiana. Sorry, I'm so yawny today. I need some coffee or something. Um, and but did anybody see what's the matter with this data? What's going to cause us problems? Oh shoot, we're out of time. Okay, I got so into it I lost track of time. All right, so we'll pick this up on Wednesday. All right, but what I wanted to say is the problem here is that this data, this numerical data, has these little single what are those called? Apostrophes? Yeah, the apostrophe crap. Sorry, the apostrophes. So we got to delete those, and we could go through each one, but I know a shortcut. So we'll start on Wednesday there. All right. All right, gang. So keep practicing on the practical tomorrow afternoon. The lab will be open from 1 to 3, so you can get in there and practice. And you just be ready to go on Thursday. All right. Talk to you on Wednesday. Bye-bye.